Today's lesson is not actually from the textbook. Today's lesson is a skill that's taught in our textbook back in chapter 5, but the way that our textbook teaches it is totally guess and check. And that's the way that it was taught to me as a student, and I found that to be incredibly frustrating because I'm not good at guess and check. And some of these problems I would literally work on for like a half hour making bad guesses over and over and over. And I just kept asking my teachers, like, there's got to be a better way. Like, it shouldn't have to be guess and check. They're like, nope, that's just the way it is. And I think maybe like my third year of teaching here or something, there's another teacher who's like, no, there is a better way. And she showed me this, and it's very cool, but it depends on factoring by grouping. So we can't do it back in chapter 5 where it kind of belongs, since we're going to be working with quadratics here, and that was a chapter 5 thing. But we have to do it after we do factoring by grouping, which we did yesterday. So we're going to review a couple of skills that are going to be important, and then we're going to put those skills together. So when we're factoring a normal quadratic, the way we learn to factor a normal quadratic is that we set up our two parentheses. We look for what multiplies to be the last number, that adds to make the middle number. And we did a little bit of that yesterday as well, but we learned that a while ago. So we're going to review that skill here because that's going to be important to us today. So in this problem, we would want to look for what multiplies to make negative 28, that adds to make a negative 12. So what would that be? Positive 2 and negative 14 can make a negative 12 and a negative 28. So it would be x plus 2 and x minus 14. So then on this one, we want to look for what multiplies to make a 16. It has to be a positive 16 that adds to make a negative 10. So what would that be? 28, and what should they be? Negatives to make a negative 10. So then, sliding, there we go. X minus 2 and x minus 8.
That's all you do?
This is the review part. So we'll use this idea and then bring some stuff into it.
Can I go ahead like that? So low.
Yes. Factoring by grouping we learned yesterday. When we factor by grouping, we learned that we group together our first two terms and our last two terms with a plus in between them. Then we look for what's common in each group, what's left in the parentheses should match, and then we pull out that matching group times the stuff that we had originally taken out. So we're going to review that here as well. So this is just a review from yesterday. So we want to group together our first two terms plus our last two terms. It always must be a plus between the parentheses. So like that negative needs to attach itself to the 9 and go into the group. Then we look for what's in common in each group. So what's in common in the first group?
So x squared.
X squared, which leaves x minus 2. What's in common in the second group?
Negative
9, and we're going to take out a negative 9. If that first number is negative, we want to get that outside of there. So we're going to divide by a negative 9, which gives us x minus 2. What's left in those groups should match, and so we pull that out to the front times the stuff that we had originally taken out, the leftovers. And that's when we can actually factor down a little bit further, x plus 3 and x minus 3 for our difference of squares. Okay, we'll do one more of this kind of a review from yesterday. So we group together our first two terms plus our last two terms. What's in common in the first group?
3x squared.
3x squared. What's left over when that comes out?
X.
3. X minus 3.
2.
X minus 2.
Okay, so divide. So dividing gives just an x left over, and then dividing gives a 2 left over. Plus, what's in common in the second group? Nothing. So what do we take out? 1, because we can always divide by 1 without changing a problem. And so then our groups match if they have to, and they come out front, times the stuff that's left over. And that doesn't break down anymore. So that's what we learned about yesterday. We're now going to combine that idea with that idea that we reviewed first to factor trinomials. Trinomial means 3 terms, where we have an x squared, so it's a quadratic, but we have a number in front of the x squared. So we haven't done that yet unless it was a special form. And otherwise, if there was a number in front of the x squared, we haven't done anything with that. Because I was told by my teachers growing up that this had to be guess and check. And it is a very long guess and check process sometimes. If the numbers have a lot of things that divide into them, then there's a lot of possibilities for guess and check. Just to kind of show what that would look like in this problem. So we have our thing we're factoring here. What I would need to do is in the front, put a 2x and an x. That's nice because there's no guessing, because that's the only way. And you don't have to write this down because this isn't the method I'm going to have you do. I'm not going to have you guess and check them. But 2x squared, the only way to do that is 2x and x. So that's not bad. 12 has some options. So to multiply and make 12, I could do 1 and 12, 2 and 6, or 3 and 4. And the thing is, because that 2 is there, the order of these numbers matters. So that means I really have 6 different things I would need to try out and think about my outsides and insides. So I would have to say, okay, first guess, let's see, 1 and 12. And if I do, screen's not sliding, there we go. If I do outsides and insides, does that make 11? Nope. Okay, so that one doesn't work, but it might work backwards. So then I try that. Does that make 11? Nope. Okay, so it's not that pair. On to the next pair, and I try that out. And this already seems like a pretty long process, having 6 things to guess. But what about if that first one wasn't just already a 2x and an x? What if that was like a 6? And then I would have to say, okay, it could be 6 and 1, or 1 and 6, or 3 and 2, or 2 and 3, in combination with any of those other ones at the end. And we start ending up with a whole lot of guess and check possibilities. And for somebody who is not very good at guessing, I found these problems to be really frustrating. So we're going to learn how to do them without guess and check. As always, in any kind of factoring, the very first thing you should do is look to see if anything divides out of every term. And it does not in this problem, but that's always something you should check for first. Once you've done that, then A is going to be in front of your x squared, B is going to be in front of your x, and C is your constant, just like it was for our quadratic formula. Then we are going to multiply together A and C, and we're going to call that D. So 2 times 12 is 24. Then we are going to make a list of numbers that add to make the middle and multiply to make 24. Okay? So I think you have a chart on your paper to put this, but I don't have a chart, so I'll just do it off to the side. That I want to multiply to make 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. And I want to find a set that I can add to make 11. So what would that be?
3 and 8.
3 and 8. Then what we're going to do is rewrite the original problem. Instead of it being 2x squared plus 11x plus 12, we're going to write it as 2x squared plus 3x plus 8x plus 12, because 3x plus 8x is 11x. So we're just breaking down that 11x into the 2 things that we just found from our chart. Then we're going to factor that by grouping. And it actually doesn't matter which order those go. So if you do 3x plus 8x or 8x plus 3x, you'll get to the same answer in the end. You can't make a wrong choice about the order of those, which is nice. So we group together for factor by grouping. We group together our first 2 terms plus our last 2 terms. What's in common in the first group? X. So I leave 2x plus 3. What's in common in the second group?
8, nothing.
4.
4. So I leave 2x plus 3. Okay? Just like yesterday, what's left in the groups should match. So then we pull that out front times the stuff we had taken out. And that's our answer with no guess and check.
What happens with the x and the 4 outside of the groups? Do they just
the x and the 4 outside of the group become the second group of our answer.
Oh, because it's the same.
Yeah, so that same group comes out front, and then the stuff that had originally come out becomes our second group.
Does it always end up like that?
Mm-hmm.
Oh, so it'll always end up like the X, or the first one on the outside of the parentheses and the second one on the outside. The inside of those parentheses will be the same.
Inside of the parentheses has to be the same, so then we'll write that just one time, that matching group, and then we'll write the stuff that we had taken out of them every time. All right, let's do some more examples. Okay, so first thing, always, first thing you do, does anything divide out of every term?
Yes.
Yes, 2. So we're going to take a 2 out. That 2 does not disappear. It has to be a part of your answer. It's just going to tag along every single step of this process. Now what we want to do is multiply together our first and our last numbers. So 3 times negative 10 is negative 30. I want to make a list of numbers that multiplies to make that. So 1 and 30, 2, 15, 3, 10, 5, 6. I want to pick a set of these that in some way can add up to make the middle value, which is negative x or negative 1. So how can I make a negative 1 out of these?
Negative 6 and 5.
Negative 6 and positive 5. Now what we're going to do is rewrite this group, instead of a negative x, a plus 5x and minus 6x, taking the numbers from the chart. So we're turning that negative x into the two things that we just said add up to make a negative x. All right, so at this point we split up the negative x into a 5x and a negative 6. And what we're going to do now is group together in there our first two terms plus our last two terms. That 2 is just going to keep on tagging along through the whole problem, not doing anything, just hanging out front. What's in common in that first blue group?
X squared.
X. So x comes out and leaves 3x plus 5. What's in common in the second group?
2.
2, and we have a leading negative, so we're going to take out a negative 2. When we divide by negative 2, what's left in there? Positive 3x plus 5. Which is good, because those should always match. If they don't match, you've done something wrong. So then, we're going to have that 2 that just keeps hanging out. We're going to have the matching group and the leftovers. And that's our final answer.
Doesn't have brackets.
We have one more example. What's in common to every one of these?
X.
A y. They all have a y. Some of them have an x. They all have numbers, but none of the numbers divide by the same thing. So they all have a y. So we're going to take that y out. Then we multiply the first and last number. 6 times negative 5 is negative 30. And we make a list of ways to multiply and get that. We want to pick the set that we can in some way make a negative 7 out of to make the middle number.
Negative 3.
Negative 10.
Negative 10 and positive 3 will make a negative 7. So then we split up in our group and make that negative 7 into a plus 3 and a minus 10. Then we apply what we learned yesterday and group together our first two plus our last two. That y in the front just keeps tagging along. What's in common in that first blue group?
2x. Or 3x.
3x. Divide that out, leaves 2x plus
3. Or I mean
0. 1.
1. Whenever we divide something by itself, that's 1. So 3x divided by 3x is 1. What's in common in the second group?
Negative 5.
Negative 5. We take that out, and we get a positive 2x plus 1. Negative 5 divided by negative 5 is 1. The group should match. the Y hangs out, the matching group, and the stuff that we had taken out originally. Okay. Questions? Your homework is in the packet. There's a 10-question worksheet, and that is what should be done for Monday.